In this video, I'm going to focus on calculating the voltage of galvanic cells and cell diagrams. Calculate the voltage of a cell constructed from Ag plus A equals Ag and Pb2 plus A equals and Pb. If we look at the standard reduction potential, we can see Pb2 plus is on the top and Ag is at the bottom. It means Pb is losing electrons or oxidized, and Ag plus gaining electrons or reduced. So we have the V for Ag plus here, that is 0.80 volt, and for Pb2 plus. So we can write half equation for this cell here. So if I write the half equation, because the Pb losing electron, so I need to write it Pb S become Pb2 plus aqueous plus 2 electron. And as Ag plus likes to gain electron, I write it this way, plus electron give me Ag. To balance the equation, the number of electrons gained by Ag plus should be equal to the number of electrons lost by Pb. So something that I need to do, I need to multiply Ag plus equation by 2 to equal the number of electrons. So I times this one by 2. As a result, it's become 2 Ag plus aqueous plus 2 electron give me 2 Ags. However, we must remember multiplying the equation by a number does not change the standard potential. So it's still 0.80 volt. If we look at the standard potential, we can see they are written for reduction. So we look at this again. So you see both this standard potential are written for reduction reaction. But by looking at this one, we see for Pb is losing electrons, so it means oxidized, but Ag gaining electron, that means it's reduced. So for Ag, still E is equal 0.80 volts. But for Pb, actually E become positive 0.13 volts because it's reverse of that reduction reaction. So if you look at this one is oxidation half equation and it's anode, and this one is reduction half equation or cathode. Just I write it here. Oxidation half equation or anode, and this one is reduction half equation or we can say this one is cathode. Right now we have E for this one and E for this one. So to calculate E cell, we just need to add this E of half cell. So I can write E cell, I put it this one to show it's a standard condition. It's equal 0.80 volt plus 0.13, that is equal to 0.93 volts. Or we can easily say E cell is equal E cathode minus E anode. That we get the same result. E cathode, we know cathode is Ag, that is E is 0.80 minus, we know E for anode from standard potential was negative 0.13, so minus E anode, so it means minus 0.13, that is equal 0.93 volts. So it's same answer. So after that, I want to see if I want to show this cell in a simple way, how I can write this cell. I can write it like this. First, I start with anode, and I say, okay, PBS in anode becomes PB2 plus aqueous. So PB losing electron become PB2 plus, and this one we know is anode. And then I put two lines, two parallel lines, as that is salt bridge. And we know in cathode, Ag plus aqueous actually gaining electron to become AgS. So we can simply show our galvanic state this way. Always we write our anode in left side and cathode in right side. Pb losing electron become Pb2 plus, salt bridge, Ag plus gaining electron to become Ag. I hope this video was helpful, and thank you for watching.